Welcome and hello. This is a support video in HEC RAS, and in this video I'm going to be talking about 1D steady flow, whether or not we should be using the flow regime for subcritical, supercritical, or mixed. So what I have on the screen is the steady flow analysis dialog box. What I'm talking about is this flow regime section right here. There's a radio button, and we're forced to select one of these three options. All right, so subcritical is basically your slower flow, less turbulent flow, which is associated with lower velocities and lower slopes. Supercritical typically associated with higher velocities and higher slopes. Of course, the Froude number, whether or not that's more than or greater than 1, is the mathematical way to determine if the flow is subcritical or supercritical. And if your 1D steady flow model has both subcritical and supercritical, that's when you select the mixed radio button. Now, as to which one do you select is a good question. My rule of thumb is to always just go with subcritical, and then I can check the Froude number after the fact. If you select subcritical, then you need to provide a downstream boundary condition. If you select supercritical, you need to provide an upstream boundary condition. And if you select mixed, you need to provide both upstream and downstream boundary condition. I'll show you where that is right now. So I'm going to just start with subcritical. I'll click that radio button. I'm going to file and save my plan. I'll close that. Then I'm going to go up to edit and then steady flow data. I have a single profile at 100 CFS. Click on reach boundary conditions. All right. So right now I have a downstream boundary condition, normal depth. It's set to 0.005. So just normal depth, 0.005. That's 0.5%. That's all I need because I'm assuming subcritical flow through the entire reach. Let's go ahead and test that and see if that's really the case or not. I'll click OK, File, Save Flow Data. Let's close that. Now go up to Run and Steady Flow Analysis. Before I click Compute, one thing I'd like to do is just toggle on the critical depth calculation. So I like to have this checkbox checked on for critical always calculated. Click OK, and let's run the model now. Okay, so that's done. I'm going to close. Let's take a look at our results. I'm going to go up to View, Cross Section. All right, so I have my three different cross sections at river station 0, 200, and 400. And in all three of those cross sections, my critical depth line right down here is below the water surface elevation. So if your normal depth is above the critical depth, then you have subcritical flow. This is cross section at river station 0, at river station 200, and at river station 400. Now, if you don't see this red dashed line, first of all, you need to toggle on the critical flow calculation, that checkbox I just showed you. And then you'd also need to go to options and then variables, and then check on this checkbox for critical depth. Click OK, and then boom, there you go. If you have multiple profiles, like multiple flows that you're making calculations for, you can also toggle those on by clicking on profiles. And then just make sure all the profiles that you want to see are over here in this right selected list box, and then click OK. Let's go ahead and check the Froude number, or we can actually look at the profile view as well. So you can go up to View, Water Surface Profiles. Another way to get to that dialog box is this button right here, Water Surface Profiles. And again, our water surface elevation, this blue line, is above the red dashed line, which represents the critical depth. Okay, let's check out the Froude number. We know it's going to be less than 1. Let's go up to View and Profile Summary Table. Here's the data. This far right column here is Froude number. It's 0.55 for all three of the cross sections. All right, let's go ahead and modify our reach here so that we have subcritical and supercritical. What I'm going to do is go into the cross-section data. I'm going to add a couple cross-sections upstream of the current most upstream cross-section, but instead of it being just a 0.5%, I'm going to make it 5%. So let's do that. River Station 400 is selected. I'm going to go Options, and then copy current cross-section and put that at River Station 600. Okay. And then what I'm going to do is go Options, Adjust Elevation. I'm going to add 10 feet here. Okay, I'm going to do that one more time here. Apply data to save. Options, copy the current cross section. I'm going to put this one at River Station 800. Okay, Options, Adjust Elevation, and that is up another 10 feet. Okay, apply, plot profile. Oops, this last one got too much elevation change. Hold on, what did I do? Okay, I added 100 instead of 10. So let me subtract 90 now. So adjust elevations, and I'm going to go -90. Okay, and then save. Let's see if that fixed it. Plot profile. There we go. Okay, well, I'm only seeing results for the bottom half, so we got to recalculate it. Let's do that now. I'm going to close this, save the geometry. Boom. I also need to update the boundary conditions. So 1 second, go to edit, steady flow data. Now the upstream most cross section is River Station 800. So I'll just put that there. We can delete this one for River Station 400, delete row from table, file, save flow data. Now I should be defining an upstream boundary condition, but I'm not going to yet. We'll wait for the error message just so you can see what that looks like. File, save, close. Okay, let's go ahead and run that steady flow simulation. If I set it to mixed and then compute, it's going to complain, missing boundary condition. It wants the upstream boundary condition defined. I can still run this as subcritical, but what's going to happen is the water surface elevation will not be able to go below the critical depth, which is not what we want. So it did run, but now if I go to view cross section, yeah, so the critical depth is right here, which is the same as the water surface elevation. And we know that's not going to be the case if we allow for mixed flow or supercritical flow. One cross section down at 600, I think we have the same situation here. Yep. But then further downstream at 400, 200, or 0, the true water surface elevation is right here. So if we run subcritical, we're not allowing the water surface to go below the critical depth. All right, let's go ahead and run a mixed flow regime this time. Before we do that, let's go ahead and add an upstream boundary condition. So edit, steady flow, click on reach boundary conditions, click on upstream, click on normal depth. I'm going to set this to 5% because that's what it is on the upstream end of our river reach. Click OK and OK. File, save flow data. Okay, we're ready to rock and roll here. Mixed flow and compute. All right, that's done. Let's check out our data. So I'm going to go up to view, cross sections. Okay, this is the bottom. Here is the top. Very nice. So now our water surface elevation is below the critical depth. That's River Station 800. Downstream of that, River Station 600, same situation. Here's the water surface elevation. Here's the critical depth. And then further downstream, we should have, yeah, subcritical flow cross sections 400, 200, and 0. Let's check that Froude number and call it good. So I'm going to go up to view, profile summary table. Okay. So here we have a Froude number of 1.6, 1.59. That's when the channel has a slope of 5%. And that's not too common. And then further downstream, where the channel is 0.5%, we have a 0.55, 0.55, and 0.55 for our Froude number. So that's it for this support video. My recommendation is to just go with subcritical, assume that it's subcritical. But if you notice that your water depth equals the critical depth, which may be a good thing to check, go ahead and select mixed and check for a potential supercritical flow regime.